Hello and welcome, guys. This is going to be a video about open-close principle, but more importantly, this is going to be a showcase of how we apply this principle at my job. So this is going to be more of a real use case scenario. So stick around. The chances are quite high that you're going to use something similar at your project. All right, I'm not going to delve into theory. I'm just going to show you problems and solutions so you can have an understanding of why this principle is important and how to apply it overall. All right, let's just jump into code straight away. Okay, so we have a function named calculate price. It receives an amount and customer type. This is a typical scenario for calculating price of a product which we are selling, or I don't know, doing something with it, and we need to calculate price for this product based on the customer type, right? So as you can see here, we're switching customer type, and if it's regular, we are multiplying by 125, if it's premium, by 115. And this is absolutely fine, nothing wrong with this function. The only problem comes if we start having more scenarios. So for example, our manager comes in and says that we need to add a luxury customer now. So we are adding luxury, then we are adding luxury scenario, and the amount is 1.1. And this is still absolutely fine. Yeah, we just added one more scenario, one more calculation, nothing difficult. But now another scenario comes in that says that based on the quantity the luxury customer purchased, we need to give him additional discount. And the quantity is stored in a database. So we are adding another function here. Let's say this is a mock of calling to database. And if he bought like a quantity above 500, we are multiplying by 0.99, right? We're giving him 1% discount. And already this is not quite good, because if you watch my previous video, this is already violating single responsibility principle, right? We are making a call to database, but let's assume this is still fine. But the next day our manager comes in and says that for premium customers, we are adding actually a new discount policy, right? And if he has discount, we need to apply a discount percentage. So here we are adding another if case scenario, right? We are providing this discount config here. And if DC discount, we must apply discount to this price. So we are multiplying it by DC percentage. Actually 1 minus percentage. Something like this. So as you can see, this code is growing and growing, and at some point it will get out of hand. It's already getting quite problematic, and I just thrown a few examples which are absolutely realistic in a real world scenario, and even some of them are even way worse. So we need to have a different approach somehow to manage like different customer types, different configs, database requests. The main problem here is that it's getting more and more problematic to add every new scenario and to customize these scenarios. The other problem, as I said, we're already violating single responsibility principle because we are making database requests here. But what if for some policy we need to make like third-party API calls? We're going to add it here. So this adds another problem, like how we're going to test this, right? We're going to mock third-party APIs. We're going to mock database just to test price calculation. The other problem is how we're going to work with other team members in parallel, right? Someone is working on luxury and I'm working on premium, and somehow we are working on the same function. We might have conflicts. We might be actually working on the same line for some reason, or someone copies this. So this can get a pretty nightmarish code pretty fast. All right, so you get the point. Now let's have a look how we can solve this using open-close principle. All right, so the problems we are trying to solve here is to be able to extend the code, to test it and work on it separately, and to deploy all the functionality separately and make sure that nothing breaks in case we change some lines, right? Just a brief pause. If you enjoy this type of content or want to watch me live code projects like this, hit subscribe button and ring that bell. It is free, takes 2 seconds, and helps me a ton. As you can see, only a very small percentage of you guys actually subscribe to my channel. Anyways, thank you very much for all the support. Let's continue. So anyways, we need to do some kind of switch casing, right, to determine which customer, which policy goes where. So for that, well, actually, I'm going to use something called policy and policy factory. And in factory, we're going to do all the mapping to understand which type applies here. and we're going to separate calculation logic into separate function, class, whatever. So we're going to add something, as you can see here, policy factory. It takes all the params we had before, right? Because there is no way to get away from there. The only thing, we are not going to be making any API requests, any database requests inside the factory. Factory will be just determining which pricing policy we're going to use. And we're going to add interface pricing policy, and this factory will be returning it. And it has, as you can see, only one method, calculate. It takes amount and essentially returns the amount, right, based on our policy. And we have our types, as we had before, regular, premium, luxury. We can add more here, but let's see what we're going to do next. So the next one we need to start adding, right, functions that will handle every type. So we will, for the regular policy, we will add regular policy class, which implements this interface, iPricing policy, right? And it calculates amount the same as it was before, multiplies by 125. Nothing special, right? So then we will add premium policy, and it takes already the discount config from before. And now we add this logic in here, but it has the same method, calculates, and it takes only amount. But into constructor, it takes a config, which it requires. And the same we will do for luxury policy, right? It takes a quantity, if you remember, and if quantity is above 500, which let's assume we take it from database, we have different logic. And this amounts as well, like by 1.5, maybe it's going to be in database and it's going to be here in config, right? And let's add luxury policy. As you can see, now we separated all the logic in its own class, in its own function, right? So basically factory is now responsible only for mapping, to understanding which policy to use. Each policy has only one method. Well, they implement interface with one method, which they require to calculate, which takes the same params and returns the same params. So now we can easily extend our logic, previous logic, right? We just add a new type here, like, I don't know, seasonal, with some special, I don't know, policy. And here we will add seasonal policy, right? And maybe it takes, in this scenario, we will have third-party API calls or anything like this, or maybe a database, everything. But the main point is that factory handles only mapping, and all the requests, everything happens before it. Let's assume we are now in the service, which will do all the orchestration. So as previously, we need to get like quantity. Let's say we have quantity, and we had this mock get quantity from the B. Yes, then we had discount config, which is discount config, has discount, let's say true, and percentage, I don't know, 1%. And then what we need to do, we need to determine our policy, right? I can just type the policy, and then we call our policy factory, and we pass everything, right? Let's assume the type is going to be luxury, then we pass our discount config and quantity, right? I'm passing everything into factory, but some params, you can turn this into object, right? Cover it with interface and make it optional. So it's not all of them required. Well, you can basically play around, but I set them all as required. And then we're getting our result. We just run policy, calculate, and provide amount. I don't know, let's say 400. And that's it, right? So now we can easily change amount, right? For example, say 600. We can change the type to regular or luxury again. Say premium, right? It's very easy, very simple, straightforward. And we separated all the logic. Right, so all database requests, all API calls going to be done beforehand. Then we pass all the required params into factory, and factory, as I said already several times, does all the determining which policy we use. Then we just run policy calculate. All right, so now let's talk about open close principle and what it is. So our classes, our functions should be open for extension and closed for modification. All right, let's understand how we achieved all of this. So now let's assume we change our database, right? We used SQL, now we use Mongo. We changed some third-party API, I don't know, service, Does it affect us? No, we just require a customer type, which will probably come from web, right, or from something, right, external. Then we pass the config, which we will just map it, right? We don't care about other external service and what changed with it. We require the same config, and we require just quantity from the database or some other parameters. It doesn't matter if it's going to be Mongo instead of SQL. So we are closed for modification in case if something changes like it was previously, right, in wrong service. In case if database changes, our code breaks. Can we test the code separately? Yeah, we can test each and every single class separately, right? We can take, for example, I don't know, regular policy, right? Just create a regular. And now regular like this, and then we can run tests on it. We can do the same with every single one of them. The same comes for working in parallel, right? Each team member can work on on his policy, and probably, well, there is a chance that you will have conflicts, but it's not going to be like before, right? You work in isolation on your own policy, so you get the point. And the most important one is that we can add new policies quite easily, right? We just add a new switch case here, we add new class for it, like seasonal, right? And then seasonal here. And then we write our own class and write required policies in it, so we can have some private functions here. Not only calculate, we can have whatever we want inside. And yeah, this is pretty much it. And I hope everything was clear, although we are using factory here and we completely refactored the wrong code, like switch case. Although we have more classes here, but now we separated concerns. Everything is responsible for its own thing, right? As I said, we are handling database API requests, everything beforehand. Then we have policy or policy factory, and then we're executing factory. So the code became way clearer and maintainable and testable, and just, I don't know, more pleasant for developers to write in such manner. Okay, once again, I hope it was helpful and clear. In case if something wasn't clear, let me know in the comments down below. Thanks for watching and take care. Bye-bye.